This interpretation appeals to cosmologists because it explains everything at once. Every mystery about the void traces back to one cause: collision with another universe. The simplicity is elegant, the economy of explanation is beautiful, but the hypothesis faces challenges. First, bubble universes are theoretical. We have no direct evidence they exist. The entire concept rests on interpretations of quantum mechanics and inflation theory that many physicists dispute. Building explanations on uncertain foundations is risky. Second, even if bubble universes exist, collisions should be rare. The probability of our universe hitting another universe precisely hard enough to leave the observed void but not destroy everything is small. We might be invoking an unlikely event to explain observations. Third, the collision should have occurred during inflation. That was 13.8 billion years ago. Any activity from that event should have faded by now. The energy from the collision should have dispersed. Remnants should be cold and inactive. Yet the void shows increasing activity. The signals grow stronger. The geometric patterns develop over time. This suggests ongoing processes, not ancient relics slowly cooling. Unless the collision did not just leave a scar but created a connection, a permanent bridge between universes. If our universe and another universe still touch at the void, matter and energy could flow between them. Information could transfer. Entities from the other universe might cross over. The void would be a cosmic border crossing, a place where two realities meet. Recent theoretical work explores what such a connection would look like. The physics at the boundary would be exotic. Neither universe's laws would fully apply. Both sets of rules would partially work. The result would be a hybrid region where bizarre phenomena become possible. This hybrid zone might explain the void's properties. The missing dark matter crossed to the other universe. The anomalous lensing results from space-time behaving according to foreign physics. The radio signals are communication across the boundary. The geometric structure bridges both universes, existing partially in each. If this model is correct, we are not alone. Another cosmos lies adjacent to ours. Different physics, different constants, maybe different types of matter and energy. And we can observe it through the void, study it, learn from it. Some researchers go further. They propose intelligence exists in the other universe. Advanced beings discovered the connection just as we did. The signals we detect are their attempts at communication. They are trying to establish contact, tell us they exist, share knowledge across the dimensional divide. This is optimistic, maybe too optimistic. Another interpretation is that the other universe is invading, using the connection to expand into our space. The geometric lattice is infrastructure for invasion. The radio signals are coordination between invading forces. The increasing activity represents invasion progress. We have no way to determine which interpretation is correct without more data. Are we witnessing first contact with beings from a parallel cosmos? Or are we watching the early stages of an interuniversal war? Either way, the void is more than an astronomical curiosity. It is the most important discovery in human history. Proof that our universe is not alone. That reality is larger than we imagined. That physics has layers we never suspected. And we are just beginning to understand what that means. Temperature measures particle motion. More motion means higher temperature. Less motion means lower temperature. Absolute zero, minus 460 degrees Fahrenheit, is the point where particles stop moving entirely. Space is cold. The cosmic microwave background radiation permeates everything with a temperature of minus 454 degrees Fahrenheit, just barely above absolute zero. This is the baseline temperature of the universe. Empty space cannot get much colder than this because the CMB keeps it warm. The Boötes Void is colder. Measurements show the void's interior registers minus 456 degrees Fahrenheit, 2 degrees colder than the cosmic microwave background allows. This is impossible according to thermodynamics. The CMB surrounds the void. It floods it with radiation from all directions. Nothing can be colder than its surroundings without active cooling. Active cooling requires work. You need to extract energy from a region and dump it elsewhere. Refrigerators do this. They pump heat from inside to outside. But space is not a refrigerator. No mechanism exists to cool cosmic voids below ambient temperature. Yet the void is colder, consistently, across its entire volume. Every measurement confirms it. The temperature drop is real. Some physicists propose dark energy causes this. Dark energy pushes space apart. When space expands, it cools. The void expands faster than normal space, according to recent observations. Maybe this accelerated expansion cools it below the CMB temperature. Calculate how much cooling expansion provides, and you get a disappointing answer. Not nearly enough. Expansion can cool space by fractions of a degree at most. The observed drop is larger. Something else must be happening. Another hypothesis suggests the void lacks the dark matter that normally helps distribute heat. Dark matter does not emit light, but it does interact gravitationally. Gravitational interactions can transfer energy. Without dark matter, energy transfer might occur more slowly. The void could cool simply because heat takes longer to enter it. This works better mathematically, but it still fails to explain why the temperature stays below the CMB. Even slow energy transfer would eventually equalize temperatures. The void should warm up to match its surroundings given enough time, and 13 billion years is plenty of time. The temperature distribution is not uniform. The coldest regions concentrate around the geometric lattice nodes. Where the 60 galaxies sit, space is coldest. The filaments connecting them show intermediate cooling. The wide open spaces between lattice elements are only slightly cooler than normal. This pattern suggests the lattice itself extracts energy from surrounding space, like a cosmic refrigerator with the galaxies as cooling elements and the filaments as heat exchangers. Energy flows from the void's emptiness into the lattice structure, then vanishes somewhere. Where does the energy go? Thermodynamics requires energy conservation. You cannot destroy energy. You can only move it or convert it. The lattice must be storing the energy or radiating it away. No excess radiation comes from the lattice. Surveys across all wavelengths show nothing unusual. The galaxies glow normally for their types. The filaments emit only the expected synchrotron radiation. No additional energy output that could account for cooling the void. So, the energy is being stored, accumulated inside the lattice somehow, building up over eons. This is deeply concerning. Stored energy can be released. If 13 billion years of cooling energy is packed into the lattice, the amount stored would be staggering. Releasing it all at once would exceed the energy of billions of supernovas. What happens when you release that much energy? Probably nothing good. You might reignite dead galaxies, tear apart nearby structures, create shockwaves that propagate across the void. The destruction would be visible from here, despite the enormous distance. Or maybe the energy is not meant for destruction. Maybe it is fuel, power for whatever the lattice is building. The geometric structure could be a machine that needs enormous energy to operate. It has been collecting fuel for billions of years. Now, it is almost ready to turn on. Recent temperature measurements show something even more disturbing. The cooling is accelerating. The void grows colder, faster now than a decade ago. Like the lattice's energy extraction rate is increasing. Like it is preparing for something that requires more power than ever before. Extrapolate the trend and the void will reach absolute zero within 10,000 years. Nothing in our universe exists at absolute zero. Quantum mechanics forbids it. Reaching true zero requires removing all particle motion, all quantum fluctuations, all zero-point energy. That is physically impossible in our space-time. Yet the void is heading there, cooling past the point where our physics says cooling must stop. This suggests the lattice can access physics beyond our understanding, or it connects to something beyond our universe where different rules apply. If the void reaches absolute zero, what happens? Do quantum effects shut down? Does space-time itself freeze? Would the void become a region where cause and effect stop working? Where time stops flowing? A bubble of absolute stillness in a dynamic universe? Or maybe reaching absolute zero is not the goal. Maybe it is a threshold, a condition that must be met before something else can happen. Like a computer waiting for its processor to cool before running a critical operation. The lattice cools the void to absolute zero, then activates. Then begins its real work. We have no idea what that work might be. We only know it requires conditions that violate everything we understand about physics. And we know those conditions are approaching rapidly. The countdown has entered its final phase. The void grows colder every day. And when it reaches zero, we will learn what the lattice has been preparing for all this time. Gravity drives clustering. Dense regions pull nearby matter inward. Over time, galaxies gather into groups. then clusters, then superclusters. The pattern is universal. Wherever we look in space, we see this hierarchical structure building naturally. The 60 void galaxies cluster wrong. They form groups that violate gravitational predictions. Some groups contain galaxies moving too fast to stay bound together. They should fly apart within a few million years. Yet they remain clustered, defying the forces trying to separate them. Other groups contain galaxies moving too slowly. Their orbital speeds suggest they feel almost no gravitational pull from each other. Like invisible walls separate them, preventing normal gravitational interaction. The galaxies stay in formation not because gravity holds them, but because something prevents them from leaving. Astronomers map galaxy velocities using Doppler shifts. When a galaxy moves toward us, its light shifts toward blue wavelengths. When it moves away, its light shifts toward red. Measure many galaxies in a group, and you can reconstruct their three-dimensional motions. The void galaxy motions show coordinated patterns, not random orbits but synchronized movements. Like dancers following choreography, 6 galaxies near the northern edge of the void move in circular paths around an empty point. They complete one orbit every 90 million years, maintaining perfect spacing between each other. Nothing sits at the center of their orbits. No massive object, no visible matter. The galaxies circle around emptiness. Calculate the mass needed to make 6 galaxies orbit at those speeds, and you need something heavier than 100 billion stars. We see nothing, absolutely nothing. This is not unusual dark matter behavior. Dark matter clumps gravitationally. It concentrates where matter concentrates. Finding a massive dark matter halo with zero normal matter inside violates every model of cosmic structure formation. Normal matter and dark matter grow together. You cannot have one without the other. Unless something removed the normal matter after the dark matter halo formed, extracted it somehow, left only the gravitational skeleton behind, the void galaxies would then orbit around ghost structures. Dark matter frameworks that once supported galaxies, but now stand empty. But why remove the matter? What process selectively destroys normal matter while leaving dark matter intact? We know of nothing that can do this. Normal matter and dark matter interact through gravity. You cannot affect one without affecting the other. Another clustering anomaly. The galaxies avoid certain regions, not randomly. Specific volumes of the void remain completely empty, even though galaxies pass nearby. These forbidden zones maintain their emptiness despite having no obvious boundaries. Galaxies that approach these regions deflect away, like they hit invisible barriers. Map the forbidden zones, and they form a pattern. Spheres positioned at regular intervals throughout the void. Where these spheres intersect, the intersection volumes also remain forbidden. The entire structure resembles a three-dimensional molecular lattice. Atoms replaced by forbidden zones, bonds replaced by allowed paths. The 60 galaxies occupy positions between the forbidden zones, slots where matter is permitted to exist. Calculate how many slots the lattice provides, and you get exactly 60, not 59, not 61. Precisely the number of galaxies we observe. This cannot be coincidence. The galaxies did not randomly settle into a pre-existing lattice. Either the galaxies created the lattice, or the lattice created the galaxies. Both options require physics beyond our current understanding. Creating forbidden zones requires force fields or energy barriers. Science fiction technology, not natural cosmic phenomena. Yet the zones exist. They shape galaxy motion demonstrably. We can measure their effects even if we cannot see them directly. Some theoretical physicists propose the zones are topological defects, regions where space-time has different properties than normal space. These defects would form during phase transitions in the early universe. They would persist indefinitely, creating permanent structural features in the cosmos. But topological defects are hypothetical. No confirmed observations exist. Using unconfirmed physics to explain mysterious observations is circular reasoning. We explain one unknown with another unknown and claim progress. The alternative is accepting that something built the lattice deliberately. Something placed 60 galaxies in specific positions and maintains forbidden zones between them. Something that operates on scales we can barely comprehend and timescales that span billions of years. The clustering patterns are evolving. Recent measurements show the galaxies slowly drifting toward more perfect lattice positions. Deviations from geometric ideality decrease year by year. The structure is refining itself, approaching a final configuration where every element sits exactly where it belongs. When that configuration completes, what happens? Does the machine turn on? Does the lattice achieve its designed function? We are watching something self-assemble across cosmic distances, an engineering project that began before complex life existed on Earth. And it is almost finished. The cosmological principle is fundamental to modern astronomy. It states the universe looks the same everywhere. No special places, no preferred locations. Every region is statistically identical to every other region when viewed at large enough scales. This principle makes cosmology possible. If different regions followed different rules, we could not extrapolate from what we observe nearby to understand distant space. We could not trust that physics works the same way across the cosmos. Science would collapse into chaos. The Boötes Void threatens this principle. It is not statistically similar to other regions. It is unique, exceptional, a place where the normal rules break down and something else takes over. Compare the void to other large voids. They show typical properties: expected galaxy counts, normal cosmic microwave background effects, standard expansion rates. They are empty but boringly so. Nothing exceptional happens inside them. The Boötes Void shows none of these typical properties. Every measurable quantity deviates from expectations. The galaxy count is too low. The CMB cold spot is too cold. The expansion is too fast. The temperature is too low. Geometric structures appear. Signals broadcast. Energy flows along filaments. This is not a statistical fluctuation. Statistical outliers happen occasionally, but they deviate from the mean in one or two properties. The void deviates in every property. The odds of this occurring randomly are infinitesimally small, essentially zero. So either we are witnessing a 1 in a trillion coincidence, or the cosmological principle is wrong. One region of space genuinely differs from all others. Physics operates differently there. The universe is not homogeneous at the largest scales. If the principle is wrong, cosmology needs rebuilding from scratch. Our models of cosmic evolution assume uniformity. They calculate how the universe changes over time by applying the same rules everywhere. Without uniformity, these models fail. We would need new models that account for special regions, places where different physics applies, zones where cosmic evolution follows alternative paths. This requires identifying what makes these zones special, what distinguishes them from normal space. The void's location might provide clues. It sits in a relatively unremarkable part of the sky, not near the galactic center, not aligned with any cosmic axis. No obvious reason why this spot would be special, yet it is. Unless the location was chosen, unless something decided this spot should become special and made it so. That implies agency, intelligence, purpose, things that cosmology does not include in its models. Some cosmologists propose we are observing a local bubble of false vacuum. In the early universe, space might have settled into different energy states in different regions. Most regions found the true vacuum, the lowest energy state. But occasionally, a region gets trapped in a false vacuum, a higher energy state that persists because barriers prevent decay to the true vacuum. False vacuum regions would have different properties than true vacuum regions, different particle physics, different force strengths, maybe even different dimensionality. These bubbles would create violations of the cosmological principle naturally, no intelligence required. The theory is elegant but faces problems. False vacuum bubbles should expand, not contract. Their higher energy drives them to grow and convert surrounding true vacuum to false vacuum. Eventually, the bubble engulfs the universe. We call this scenario vacuum decay, and it represents a possible end of everything event. The Boötes Void is not expanding to engulf everything. It is growing but slowly, not fast enough to threaten the wider cosmos. If it is a false vacuum bubble, it is the most stable bubble imaginable. Something prevents it from decaying or expanding catastrophically. Maybe the geometric lattice provides stability. The structure could regulate vacuum decay, keep the bubble from growing too fast or collapsing. An engineered solution to what is normally a runaway process. This interpretation blends natural and artificial explanations. The void started as a natural phenomenon, a false vacuum bubble that formed randomly, but something discovered it, recognized its unique properties, built the lattice to stabilize and control it, transformed a natural curiosity into a useful tool. What uses does a controlled false vacuum bubble have? Inside the bubble, physics differs from outside. You could use different physical laws, access higher energy states, perform processes impossible in normal space. The bubble becomes a physics laboratory or industrial facility operating under customized rules. The radio signals might be readouts from experiments. The dimming events might be manufacturing processes. The energy flowing through filaments might power exotic physics that requires conditions we cannot naturally create. This suggests the void is not a threat. It is infrastructure, built by beings so advanced they can manipulate fundamental physics. They chose this location because it already had unusual properties. They enhanced those properties, created a facility that spans 100 million light-years. But if they built it, where are they? Why does the facility seem abandoned? Why do we detect signals, but no obvious operators? Either the builders are long gone, or they are so different from us that we cannot recognize them even when looking directly at their works. Or maybe they are not gone. Maybe they are watching, waiting to see if we figure out what we are looking at, testing whether humanity can recognize artificial structures on cosmic scales, deciding whether we are ready for contact. The cosmological principle always seemed too good to be true. The idea that nothing in the universe is special, that we occupy no privileged position. It is comforting philosophically, but reality does not care about our comfort. The void proves some places are special, and if one place is special, others might be too. We might find more structures like this, more engineered cosmic facilities, an entire infrastructure spanning the observable universe that we mistook for natural formations. Everything we thought we knew about the cosmos might be wrong, and we are just beginning to glimpse the truth. Our universe has 3 spatial dimensions: left, right, forward, backward, up, down. Plus time makes 4 dimensions total. We live in 4-dimensional space-time. Everything we experience exists within these dimensions. But physics suggests more dimensions exist. String theory requires 10 dimensions. M theory needs 11. These extra dimensions are hidden from us, curled up so small we cannot detect them, or maybe oriented in ways our 3-dimensional senses cannot perceive. What if the void connects to these extra dimensions? What if the signals we detect are echoes from higher dimensional space? What if the geometric lattice is a projection of a structure that exists primarily in dimensions we cannot see? This idea sounds far-fetched, but it explains observations that nothing else explains. Start with the missing dark matter. Dark matter might not be missing. It might have shifted into an extra dimension where we cannot detect it gravitationally. The void could be a region where dimensional barriers are weak, where matter slips between dimensions more easily than elsewhere. The geometric lattice's impossible precision makes sense if it is a shadow of a higher dimensional structure. In higher dimensions, creating perfect geometric patterns is easier, like how a 3-dimensional sphere casts a perfect circle shadow on a 2-dimensional surface. The lattice we observe might be the 3-dimensional shadow of a 4-dimensional or 5-dimensional object. This would explain why the structure seems to defy physics. It is not fully in our space. Most of it exists elsewhere. We only see the part that intersects our dimensions. Like watching someone's hand pass through a sheet of paper. The hand is 3-dimensional, but the paper dwellers only see a 2-dimensional cross-section. The radio signals might be dimensional leakage. Energy propagating through higher dimensions occasionally crosses into ours. We detect these crossing events as broadcasts. The 14-day periodicity reflects the geometry of higher dimensional space. The signal's path through extra dimensions creates a delay that manifests as regular timing in our dimensions. Recent experiments in particle physics searched for signs of extra dimensions. They found none, but those experiments probed tiny scales, subatomic distances. Extra dimensions might be large on cosmic scales while remaining hidden at particle scales. The void could sit at a location where cosmic scale extra dimensions become accessible. Calculate what a 4-dimensional sphere would look like passing through our 3-dimensional space. It would appear as a sphere that grows, then shrinks. First small, expanding to maximum size, then contracting back to nothing. The entire sequence would look like an object that appeared from nowhere, changed size, and vanished. The dimming events follow this pattern. Galaxies dim when the four-dimensional object passes through our space, blocking their light. The dimming magnitude varies with time because different parts of the four-dimensional object have different sizes. The 78-day cycle is how long the object takes to pass completely through our dimensional slice. This interpretation requires 17 different four-dimensional objects, or one extremely large four-dimensional structure with 17 parts that intersect our space at different times. Either way, we are detecting something that exists mostly outside our perceptual range. The temperature drop makes sense dimensionally too. Heat in our 3 dimensions might flow into extra dimensions where we cannot measure it. The void is not colder because energy is destroyed. It is colder because energy escapes into dimensions our thermometers cannot access. The lattice might be a heat pump that transfers energy dimensionally. Higher dimensions provide natural explanations for faster-than-light effects too. If signals can shortcut through extra dimensions, they would appear to travel faster than light in our 3 dimensions. Like an ant walking on a rolled-up piece of paper, the ant sees a long path across the surface. But if the ant could cut through the paper's thickness, the journey would be much shorter. The void might be a cosmic shortcut, a region where extra-dimensional paths become accessible. Signals and matter could enter the void, transit through higher dimensions, and emerge elsewhere in our universe almost instantaneously. The geometric lattice could be the entrance structure, a dimensional gateway. If true, this is staggering. Faster than light, travel might be possible using higher dimensional shortcuts. The void becomes more than an astronomical curiosity. It becomes a potential transportation hub, a natural wormhole network built into space-time structure. But there is a darker possibility. What lives in extra dimensions? If dimensions beyond our perception exist, they could harbor entities we cannot detect. Beings that exist primarily in 4-dimensional or 5-dimensional space. To them, our 3-dimensional universe might be like a surface they can view from above. These beings would see everything in our universe simultaneously, all of space at once. They could reach into our dimensions at will, manipulate matter and energy, using forces we cannot perceive. They would be effectively omnipotent from our perspective. The lattice might be their construction. Infrastructure built by higher dimensional entities for purposes we cannot comprehend. We are trying to understand a 4-dimensional machine using only 3-dimensional observations, like a painting trying to understand the artist. Recent theoretical work explores what signatures higher dimensional objects would leave. They predict specific patterns in gravitational waves, unusual correlations between distant regions of space, violations of energy conservation that resolve when you account for extra dimensions. The void shows all these signatures. The gravitational wave detectors pick up that persistent hum. Distant void galaxies show coordinated behaviors. Energy appears and disappears without clear sources or sinks. Every anomaly points toward dimensional physics. If we are detecting another dimension, the implications are profound. Our universe is not isolated. It connects to a larger reality. Other dimensions exist and interact with ours. The void is where that interaction is strongest, and something in those other dimensions is very interested in our space. They built structures spanning hundreds of millions of light years. They maintain them actively. They broadcast signals into our dimensions. They are trying to establish contact or prepare for something. We cannot see them directly, but they can see us, and they are getting ready to act. Computer simulations are astronomy's crystal ball. We cannot wait billions of years to watch cosmic evolution. So we program physics into computers and let them calculate what should happen. These simulations predict how galaxies form, how voids grow, how cosmic structures evolve. The simulations are sophisticated. They model gravity, dark matter, dark energy, gas dynamics, star formation, billions of particles interacting over cosmic time. The results match observations beautifully. Galaxy distributions, void sizes, cluster masses, everything checks out. Except the Boötes Void. The simulations cannot reproduce it. No matter what initial conditions researchers use, no matter what parameters they adjust, they cannot create a void like this one. Run 1,000 simulations. None produce a void 330 million light-years across. The largest voids in simulations top out around 200 million light-years. Increased dark energy, strength, and voids grow larger, but other structures break. The universe becomes unstable. Galaxies fly apart. Reality fails to match observations everywhere else. So researchers try different approaches. Maybe the void started with unusual initial conditions, a region that began with much less matter than average. They program this into simulations and watch what happens. The underdense region does grow into a void, but it evolves wrong. It should form earlier than observed, or later. Never at the right time with the right properties. The timing does not work regardless of how you tune the parameters. Try another approach. Maybe something happened after the Big Bang, an event that carved out the void. Researchers simulate explosive events, matter ejections, energy bursts. Nothing creates the observed structure without destroying nearby galaxies. The geometric lattice is even more problematic. Natural simulations never produce geometric patterns. Gravity creates clumps and filaments, but always irregularly. Random processes cannot generate the precise symmetry we observe. Some researchers insert artificial structures into their simulations, place 60 galaxies in a geometric lattice, add connecting filaments, then let physics evolve the system forward. What happens? The lattice collapses immediately. Galaxies fall toward each other. Within a few million simulated years, they merge into clumps. The geometric pattern disintegrates. No natural forces maintain the structure against gravity's pull. Add dark matter concentrations at lattice nodes, strengthen magnetic fields along filaments. Still, the structure collapses. You can slow the collapse, but not stop it. Eventually, gravity wins, and the pattern disappears. Only one configuration remains stable. When researchers add invisible masses precisely calculated to balance every force, the lattice persists. But these masses must be placed with exquisite precision. Shift any mass by even 1% and the lattice destabilizes. This level of precision requires fine-tuning. Everything must be exactly right or nothing works. Natural processes do not fine-tune. They are sloppy, approximate. Only intelligence fine-tunes because only intelligence can calculate required values and implement them precisely. The simulations also fail to reproduce the void's expansion rate. Code the observed galaxy positions and velocities into a simulation. Run it backward in time. Where were these galaxies a billion years ago? 10 billion years ago? At the Big Bang? The trajectories do not work. Traced backward, the galaxies do not converge on reasonable starting points. Some come from directions where no matter existed. Others move on paths that require them to pass through each other. The history does not make physical sense. It is like watching a movie run in reverse and seeing impossible things, objects appearing from nowhere, trajectories that violate conservation laws. The void's current state cannot arise from any plausible past state through natural evolution. Some researchers propose the simulation physics is incomplete. We are missing crucial processes. Maybe dark energy behaves differently than we modeled. Maybe dark matter has additional interactions. Add the right missing physics, and perhaps simulations will reproduce the void. But what missing physics? Every adjustment researchers try either fails to help or breaks other predictions. Fix the void, and you destroy galaxy formation elsewhere. Or you violate CMB observations. Or you contradict gravitational wave detections. The observations form an interconnected web. Touch one strand, and the whole web shifts. The most disturbing simulation results come from forward evolution. Take the void's current state. Run simulations forward in time. What happens in the future? The simulations crash. Literally. Within a few 100 million simulated years, the equations become unsolvable. Infinities appear. Physical quantities diverge to impossible values. The computer cannot calculate what happens next because the math breaks down. This has never happened before with cosmic simulations. You can simulate the universe from the Big Bang to heat death without problems. But simulate the void forward and you hit a wall, a point where physics stops working. Mathematicians recognize this signature. It appears when you try to model singularities, points where space-time curvature becomes infinite. Like black hole centers, the equations break because the situation exceeds the limits of classical physics. Is the void creating a singularity? Is it building toward a point where space-time itself breaks? The simulations suggest this happens in 500 million years, maybe less. The lattice's growing activity might accelerate the timeline. When physicists simulate black hole formation, they know what causes the singularity. Matter compresses to infinite density. Gravity overwhelms all other forces. The result is predictable, even if the math breaks. The void's approaching singularity has no obvious cause. Nothing is compressing. No runaway gravity. The region is empty. Yet simulations show space-time curvature increasing without limit. Like the void is generating a naked singularity, a breakdown of physics without any matter present. Naked singularities are forbidden by cosmic censorship hypotheses. They should not exist. They would allow violations of causality, time travel paradoxes, signals from the future affecting the past. Physics becomes inconsistent. But the simulations show one forming anyway, in the emptiest region of observable space, at a location marked by an artificial geometric structure. The void is not just unusual, it is building toward an event that should be physically impossible. And when that event occurs, our simulations cannot tell us what happens next. We are blind to the future beyond that point. The void is creating its own horizon, a limit to predictability, a boundary past which science cannot see. We are running out of time to understand. The singularity approaches, the lattice activates, and we still do not know what it is for. Mass and energy warp space-time. We measure this warping and calculate how much mass caused it. This technique lets us weigh cosmic structures, even when we cannot see them directly. It reveals dark matter, maps galaxy cluster masses, shows us the universe's mass distribution. Apply this technique to the void, and you get a shocking result. The region weighs wrong, not slightly wrong, catastrophically wrong. The mass deficit equals 10,000 galaxy clusters. Matter that should exist does not. Each galaxy cluster contains hundreds of trillions of times the mass of our planet. Multiply that by 10,000, and you have a mass deficit that exceeds the visible matter in millions of galaxies. We are not talking about missing dark matter anymore. We are talking about missing everything. Where did it go? Matter does not simply vanish. Energy conservation is one of physics' most fundamental laws. You cannot destroy mass energy. You can only convert it to different forms or move it elsewhere. 10,000 galaxy clusters worth of mass energy went somewhere. Calculate when the mass disappeared and you cannot. The void has been undermassive since we first measured it. Historical data shows the deficit existed decades ago. Extrapolate backward, and it existed billions of years ago. The matter never arrived in the first place or vanished so long ago that we cannot determine when. Some cosmologists propose primordial conditions. Maybe this region always had less mass than average. The Big Bang distributed matter unevenly. By chance, this spot received far less than it should. The underdensity persisted and grew into the void we observe. Calculate the probability of such an extreme underdensity forming naturally, and you get numbers with dozens of zeros after the decimal point. Essentially impossible. Statistical fluctuations do not create outliers this extreme, not in a universe of finite size and age. Another theory suggests a cosmic catastrophe. Maybe a galaxy supercluster formed in this region billions of years ago. Then something destroyed it. A collision with antimatter, a vacuum decay bubble, some unknown disaster that annihilated mass on unprecedented scales. But antimatter annihilation produces gamma rays. We should see residual radiation from such an event. Space remembers catastrophes. Energy released cannot simply disappear. It must thermalize and remain detectable. We see no such residue. Vacuum decay leaves different signatures. A bubble of true vacuum, expanding at light speed, would create visible boundaries. The bubble wall should be blazingly bright as it converts false vacuum to true vacuum. No such boundary exists around the void. The edges look normal. The third possibility is theft. Something took the mass, extracted it from our universe deliberately, transported it elsewhere, or converted it to energy and used it. 10,000 galaxy clusters of matter represents a power source beyond comprehension. What could you do with that much energy? You could power civilizations, light up entire galaxies artificially, manufacture planets, stabilize wormholes, manipulate space-time on cosmic scales. The missing mass might be fuel. consumed by a process so advanced we cannot recognize it as technology. The geometric lattice could be what remains. Infrastructure built using a fraction of the missing mass. The rest was converted to energy and expended. The lattice is the finished product. The structure that required 10,000 galaxy clusters to construct. This is a terrifying amount of engineering. Humans struggle to move single asteroids. This hypothetical civilization moves galaxy clusters. The scale difference is like comparing an ant to a galaxy. We cannot even conceptualize engineering on such levels. Recent surveys searched for the missing mass's signature. If it was converted to energy, even perfect conversion produces some waste heat. The second law of thermodynamics guarantees this. Perfect efficiency is impossible. Some energy must leak as thermal radiation. Calculate the maximum possible efficiency and determine minimum waste heat. Search for this excess heat around the void. Surveys found nothing. No temperature excess. No unexpected infrared radiation. Either the conversion efficiency exceeded theoretical limits, or the waste heat radiated into dimensions we cannot observe. The latter option ties back to higher dimensional theories. If the lattice connects to extra dimensions, waste heat could dump there. Our instruments would never detect it. The process would appear impossibly efficient from our limited perspective. Map the mass deficits distribution and it follows the geometric lattice. The nodes show the deepest deficits. The filaments show moderate deficits. The empty regions between lattice elements show minimal deficit, like mass was selectively removed from specific locations, harvested according to a plan. This selective extraction rules out natural processes. Nature does not preferentially remove mass from geometric patterns. Gravity clumps matter everywhere equally. Only intelligence removes matter selectively. Only engineering creates structured voids. The deficit is growing. Year by year, the void weighs slightly less. The rate is small. Only a few galaxy masses per year disappear, but consistent, ongoing, like the extraction process never stopped, like something still feeds on the void's matter. What happens when the deficit reaches a critical threshold? Is there a limit to how much mass can be removed before space-time destabilizes? The simulations crash before they can answer this question, but they crash for a reason. The mathematics suggests instability ahead. Maybe the lattice is preventing that instability, carefully removing mass while maintaining space-time integrity, walking a knife edge between collecting resources and destroying the region. Advanced engineering that keeps cosmic structure stable despite massive matter extraction. Or maybe instability is the goal. Maybe the entire project aims to destabilize this region deliberately, create a breakdown in space-time, a rupture that serves some purpose we cannot fathom. The missing mass is not waste, but sacrifice. Material removed to achieve a specific catastrophic outcome. Either interpretation leads to the same conclusion. The void is an active engineering project. Something is reshaping cosmic structure on the largest scales we can observe. Using technology so advanced it appears indistinguishable from fundamental physics. And we just noticed, after billions of years of construction, humans finally developed instruments sensitive enough to detect the project. We are watching the final stages of something that began before our planet existed. The question is whether we can understand what we are seeing before it finishes, or whether the completion will surprise us as thoroughly as the discovery did. Astronomers observe the universe across many wavelengths: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Each wavelength reveals different phenomena. Hot gas glows in X-rays, dust shines in infrared, stars dominate visible light. Most cosmic structures appear in some wavelengths, but not others. Galaxy clusters blaze in X-rays from their hot gas, but barely show in radio. Dust clouds hide in visible light, but glow in infrared. Look at the same region in different wavelengths and you see completely different things. The Boötes Void appears in all wavelengths. Every telescope aimed at this region, regardless of what frequencies it observes, detects anomalies. This is unprecedented. No other structure shows universal wavelength signatures. Start with radio observations. The void is radio faint. Fewer sources emit radio waves than in normal space, expected for an empty region. But the structure within that faintness is wrong. The geometric patterns, the periodic broadcasts, these should not exist. Move to microwaves. The cosmic microwave background cold spot. temperature depression that violates thermodynamic expectations, visible across the entire microwave spectrum, not just one frequency, but all of them. The cooling is wavelength independent. Infrared shows the temperature deficit extending to longer wavelengths. Dust that should radiate heat does not. The void is darker in infrared than surrounding space, but it also shows those elevated edge temperatures, the simultaneous cooling and heating that makes no sense thermally. Visible light reveals the geometric lattice directly. The 60 galaxies arranged impossibly. Their coordinated dimming, the filaments connecting them, everything visible to optical telescopes screams artificial organization. Ultraviolet imaging shows stellar populations. In the void, galaxies are wrong, too old, too red. Stars that should have died billions of years ago somehow persist, like time flows differently for them. X-rays should show hot gas. The void should be dark in X-rays because gas evacuated. Instead, X-ray telescopes detect faint, structured emission, lines connecting lattice nodes. Evidence of million-degree gas where no gas should exist. Matter that is simultaneously absent and present. Gamma rays complete the picture. These highest energy photons typically come from violent events, black hole jets, supernova remnants, active galactic nuclei. The void shows none of these sources. Yet gamma ray detectors find diffuse emission throughout the region, low intensity but persistent, a background glow that has no obvious origin. Each wavelength alone shows anomalies. Together, they form a picture of something profoundly wrong with this region. The void is not just empty space. It is space that behaves abnormally across all energy scales. From the lowest radio frequencies to the highest gamma rays, everything is off. Some wavelengths that should correlate do not. Hot gas produces both X-rays and visible light from excited atoms. The void's X-ray and visible emissions do not match. They show different structures, like two separate phenomena occupy the same space without interacting. This is characteristic of higher dimensional objects. Something that exists primarily in extra dimensions would interact with our space-time differently at different energies. Lower energy photons sample one aspect. Higher energy photons sample another. The wavelength dependence reflects dimensional structure, not physical composition. Researchers created multi-wavelength maps, overlay radio, infrared, visible, and X-ray observations. The geometric lattice appears in all of them, but with different details emphasized. Radio shows the communication network. Infrared shows energy flows. Visible shows matter distribution. X-rays show high-energy processes. Combine all wavelengths, and you see a complete picture, a machine, an enormous structure that operates at all energy scales simultaneously. Each wavelength reveals one component. The full structure only becomes apparent when you see everything at once. This multi-wavelength coherence is smoking gun evidence for engineering. Natural phenomena look different at different wavelengths because they involve different processes at different energies. Only designed systems maintain coherence across all observational bands. Only machines built with specific purposes show coordinated multi-wavelength signatures. The void is a machine. We can say this now with confidence. The wavelength data proves it. Whether biological or technological, natural or artificial, it is clearly a structured system with components operating at all energy scales. Recent observations added neutrino detection to the wavelength catalog. Neutrinos barely interact with matter, they pass through entire planets. Detecting cosmic neutrinos is extraordinarily difficult, requires massive underground detectors filled with ultra-pure water. These detectors found neutrino excess from the void's direction. Not many, just a few more neutrinos than expected from background, but statistically significant. The void produces neutrinos. Something inside generates these ghostly particles and sends them streaming through space. Neutrinos come from nuclear reactions, fusion in stars, radioactive decay, particle collisions in high-energy environments. The void contains almost no stars, almost no matter. What nuclear processes produce its neutrinos? Perhaps the lattice runs on fusion, enormous reactors powered by hydrogen extracted from sparse void gas, converting mass to energy to power whatever the structure does. The neutrinos would be fusion byproducts, unavoidable waste from matter to energy conversion. Or the neutrinos might be intentional signals, particles specifically chosen because they pass through everything. A communication method that cannot be blocked. Messages sent in neutrino pulses that traverse the universe unimpeded. Either way, neutrino emission adds another layer to the multi-wavelength picture. From the longest radio waves to the shortest gamma rays to neutrinos that barely interact at all, the void speaks in every language of physics. It is calling out across all possible channels, announcing its presence in every way matter and energy can manifest. Like something that wants to be found, that is waiting for someone to develop instruments sophisticated enough to see it completely. We finally have those instruments. We can observe across the full electromagnetic spectrum, plus neutrinos and gravitational waves. We have the capability to see the void as it truly is. And what we see is unmistakable. A machine built on cosmic scales, operating for billions of years, using physics we barely understand to accomplish goals we cannot determine. But now that we can see it, now that we recognize what we are looking at, the machine's behavior is changing. The signals intensify. The structure activates more fully, like it was waiting for us to notice, like being observed was part of its purpose all along. Scientists split into two camps. One side believes the void represents genuine, exotic physics, parallel universe collision, higher dimensional contact, artificial megastructure, something real and unprecedented. The other side believes we are making measurement errors, misinterpreting data, seeing patterns in noise. The skeptics have valid arguments. Extraordinary claims require extraordinary evidence. The void's properties are so unusual that systematic errors seem more likely than revolutionary physics. Maybe our instruments miscalibrate. Maybe multiple small errors compound into apparent impossibilities. Maybe we are fooling ourselves. Instrument error happens constantly in astronomy. Telescopes malfunction, detectors drift, calibrations slip. Careful scientists check and recheck everything. They search for mundane explanations before invoking exotic ones. This is proper scientific method. The void passed every check. Multiple independent teams using different telescopes confirmed each anomaly. Radio observations from the Very Large Array, optical imaging from Hubble and ground-based observatories, X-ray data from Chandra, infrared from Spitzer, all tell the same story. The void is abnormal. Statistical analysis shows the probability of coordinated measurement errors across all these independent systems is negligible. You would need every major telescope to malfunction in precisely the same way. The instruments would need to conspire to create consistent fake signals. This is absurd. Skeptics shifted arguments. Maybe the anomalies are real but natural. Maybe we discovered new physics that is not exotic, just unknown. Dark matter could behave differently than expected. Dark energy might have additional properties, standard physics with tweaks, not revolutionary changes. But every tweak that explains one void anomaly breaks something else. Make dark matter self-interacting strongly enough to explain missing mass, and you violate galaxy cluster observations. Modify dark energy to accelerate void expansion, and you destroy CMB predictions. The anomalies form a connected web that resists piecemeal explanations. The parallel universe hypothesis addresses all anomalies simultaneously. If our universe touched another universe at the void's location, everything makes sense. The unusual size, the missing mass, the geometric structures, the multi-wavelength signatures. One cause explains everything. This economy of explanation appeals to physicists. Occam's razor suggests the simplest explanation is usually correct. One universe collision is simpler than dozens of independent, unlikely events coincidentally happening in the same location. But parallel universes are unproven, theoretical possibilities, not confirmed realities. Building explanations on speculative physics is risky. If parallel universes do not exist, the hypothesis collapses entirely. Recent developments favor the exotic explanation. The signals are becoming too obvious to dismiss. The 14-day radio broadcasts do not fluctuate or drift. They maintain perfect timing for years. Natural astrophysical processes are never this stable. Pulsars drift. Variable stars change period. Only artificial sources or fundamental physics maintains such precision. The geometric lattice is even more damning. When independent skeptical teams measured galaxy positions, they confirmed the geometric relationships. Triangulation from multiple viewpoints rules out projection effects. The lattice is real and three-dimensional. Natural processes do not create three-dimensional geometric crystals spanning hundreds of millions of light-years. At some point, skepticism becomes denial. When every test confirms exotic behavior, when mundane explanations all fail, you must accept that something genuinely unusual is happening. The void crossed that threshold. Even hardened skeptics now admit something unprecedented exists there. The debate shifted from whether the void is unusual to what exactly it represents. Parallel universe contact remains one possibility. But higher dimensional physics, vacuum decay bubbles, and artificial megastructures also fit observations. Multiple exotic explanations compete. All agree the void is not normal space. Some researchers take a middle position. Maybe the void started as a natural anomaly that something discovered and modified, a naturally occurring flaw in space-time that an advanced civilization recognized and exploited. The initial formation was coincidence. The current structure is engineering built atop that foundation. This compromise satisfies neither skeptics nor exoticists, but might be closest to truth. Nature provided unusual starting conditions. Intelligence took advantage and built something. The void is partially natural, partially artificial, hybrid between cosmic accident and deliberate construction. Distinguishing between competing exotic explanations requires new observations. If it is parallel universe contact, we should detect particles or forces unknown in our physics. If it is higher dimensional, we should see correlations between distant void regions that suggest shortcut connections. If it is artificial, we should find optimization, components arranged for maximum efficiency given constraints. Recent analysis found that optimization signature, the geometric lattice, is not just any geometric arrangement. It is the optimal configuration for its size given certain engineering constraints. Specifically, it minimizes energy expenditure while maximizing connectivity between nodes. This is what engineers call an optimal solution. Natural processes do not optimize. They settle into local minima, good enough solutions, not perfect ones. Only intelligence optimizes, because only intelligence can evaluate many possibilities and choose the best. The void's optimal geometry is strong evidence for artificial origin, but this raises uncomfortable questions. Who built it? Why? When? If it is artificial, it represents engineering capabilities that dwarf human comprehension. The builders could manipulate matter on cosmic scales. They could maintain structures for billions of years. They might still be watching their creation. And if they are watching, they know we discovered it. Our observations are not passive. Every telescope pointed at the void broadcasts our presence. The builders, if they exist, know intelligent life has emerged in their observable region. They know we are studying their structure. What happens next depends on their intentions. Are we ants who stumbled onto a power station beneath their notice? Or are we interesting enough to contact? Will they reach out? Will they explain what the void is for? Or will they view us as threats? Primitive beings who might someday interfere with their project, better eliminated now than allowed to develop further? We do not know. We can only watch the void and hope that whatever controls it is indifferent or benevolent, because if it is hostile, we have no defense against entities that engineer on such scales. The measurement error hypothesis is looking more attractive every day, but the data will not cooperate. The anomalies persist. The void is real, and we must face whatever that reality implies. For decades, the Boötes Void stood alone, an isolated mystery. No other void showed comparable properties. Astronomers assumed it was unique, a one-in-a-universe oddity. Then, last year, surveys discovered similar structures, not identical but disturbingly parallel. 3 other voids in distant sky regions showed geometric lattice patterns, smaller than Boötes, less developed, but unmistakably similar in organization. The first discovery came from the Sloan Digital Sky Survey. Automated algorithms searching for cosmic voids flagged an unusual structure 90 degrees away from Boötes. The Eridana supervoid, larger than typical voids but smaller than Boötes, about 200 million light-years across. Deep imaging revealed 40 galaxies inside arranged geometrically. not as perfect as the Boötes lattice, but clearly structured. Triangular patterns, regular spacing, the signature of organization rather than randomness. The Boötes Void also shows radio emissions, different frequency than Boötes, 28-day periodicity instead of 14, but unmistakably similar in character. A source broadcasting on schedule from deep within the void. 2 months later, surveys found another structured void, the Sculptor Void in the southern sky, 150 million light-years across, 23 galaxies in geometric arrangement. Radio emissions every 41 days. Again, similar but not identical to Boötes. Most recently, the Canes-Venatici Void revealed itself, smallest of the group at 100 million light-years, only 15 galaxies, but perfectly arranged. 7-day radio periodicity, the youngest or least developed of the structured voids. 4 voids total now known with similar properties. All show geometric galaxy arrangements. All broadcast radio signals periodically. All display temperature anomalies and missing mass. The pattern is unmistakable. This changes everything. The Boötes Void is not unique. It is the largest and most developed member of a family, a category of cosmic structures we never knew existed. Structured voids appear throughout observable space. Map the 4 voids' positions and you find they distribute evenly across the sky, not clustering in one region but spread out, like they are sampling different parts of the universe, or like they were placed deliberately to maximize coverage. Calculate distances to all 4 voids. They sit at different depths. Boötes is closest, at 300 million light-years. Eridanus lies at 400 million. Sculptor at 500 million. Canes-Venatici at 600 million. They form a sequence in distance, not just position. This sequence matters. Light from Canes-Venatici left there 600 million years ago. We see it as it was in the ancient past. Sculptor shows how these structures looked 500 million years ago. Eridanus at 400 million. Boötes gives us the most recent view. We are seeing temporal evolution. The 4 voids represent stages in a development process. Canes-Venatici shows early structure. Sculptor is more developed. Eridanus more so. Boötes is nearly mature. We are watching these objects grow over cosmological time. Project this sequence forward. What does a fully mature, structured void look like? Take the Boötes Void as 90% developed. What appears when it reaches 100%? The other voids give us clues but not complete answers. One pattern emerges clearly. The voids grow larger over time. The lattices become more complex. The radio broadcast frequencies decrease, like the structures expand and their internal components slow down, or like they are winding up, building toward activation. Another team searched for even more structured voids. They analyzed data from entire sky surveys, looking for any void with geometric galaxy arrangements. They found 6 additional candidates, less certain than the confirmed 4, but suggestive. Possible structured voids at various developmental stages. If these candidates hold up, we have 10 structured voids in the observable universe, probably more in regions we have not surveyed carefully. These structures might be common. Hundreds or thousands could exist throughout cosmic space. This suggests a production process. Something creates structured voids regularly, either a natural process we do not understand or deliberate construction happening galaxy-wide. Either way, the universe contains an infrastructure we never suspected. Compare the structured voids to normal voids. Normal voids show simple expansion. Galaxies flee the interior. The region empties over time. Nothing complex happens. Structured voids show the opposite. Galaxies organize. Lattices form. Activity increases. They become more complex over time. 2 classes of voids exist: simple and structured. Simple voids are natural, consequences of cosmic evolution. Structured voids are something else, purpose-built or at least actively organized. The universe is not uniform. It contains processed regions, areas where something happened beyond standard cosmic evolution. The 4 confirmed structured voids show another commonality. They all align with galaxy supercluster complexes. Boötes sits between the Virgo and Hercules superclusters. Eridanus borders the Cetus supercluster. Sculptor neighbors the Fornax cluster. Canes-Venatici lies near the Coma supercluster. This positioning cannot be coincidence. Structured voids form near high-density regions. They use proximity to galaxy concentrations. Maybe they feed on nearby matter, or maybe they need dense surroundings to define their boundaries clearly. Either way, the correlation suggests these structures interact with their environments. They are not isolated phenomena, but integrated components of large-scale cosmic architecture. Nodes in a network, elements of a larger system. Researchers now search for connections between structured voids. Do they communicate with each other? Do the radio broadcasts synchronize somehow? Calculate light travel time between voids and check whether signal periodicity accounts for propagation delay. Preliminary results show possible correlations. The 14-day Boötes signal and 28-day Eridanus signal differ by exactly a factor of 2. Could be coincidence, or could indicate relationship. One signal is the harmonic of another. Like octaves in music, if the voids communicate, they form a network spanning billions of light years. Messages would take hundreds of millions of years to propagate between nodes. Yet the network could still function on cosmic timescales, passing information across the observable universe over epochs. What would such a network do? Coordinate cosmic engineering, monitor universe evolution, implement some project that requires coordination across vast distances. The possibilities are staggering. Humanity discovered not just one anomaly, but a pattern of anomalies, a system, an architecture built into cosmic structure. We thought we understood the universe's large-scale organization. We were wrong. The universe contains infrastructure, and we just noticed it. Everything changes now. The universe is not what we thought. Empty space is not empty. Voids are not passive. Cosmic evolution is not purely natural. Something else operates at scales we barely perceive. The structured voids represent the largest coherent structures ever discovered. They span hundreds of millions of light years. They contain geometric arrangements of galaxies. They broadcast signals across cosmic distances. They maintain themselves for billions of years. Nothing natural does this. Nature creates clumps and filaments through gravity, random distributions, smoothed by physical forces. Structured voids are different. They are organized, purposeful. Whether artificial or representing new physics, they are fundamentally different from normal cosmic structures. If they are artificial, the implications are clear. Advanced intelligence exists on scales that make human civilization look like bacteria. These beings manipulate galaxies the way we manipulate atoms. They build structures that last longer than most stars. They engineer space-time itself to suit their purposes. We are not alone, not even close. The universe contains entities so far beyond us that we cannot comprehend their simplest technologies. We are ants who discovered a power grid. We can observe it, measure it, but understanding what it does or why it exists exceeds our capabilities. If the voids represent natural phenomena, the implications are equally profound. Physics operates in ways we never imagined. Higher dimensions exist and interact with ours. Parallel universes touch at specific locations. Space-time has architecture we never suspected. Either interpretation rewrites textbooks, either demands complete reconsideration of cosmic evolution. The universe is not a simple expansion from hot, dense origins, gradually cooling and organizing through gravity. Something else happens, something we are only now beginning to detect. The structured voids are growing. Activity increases year by year. Whatever process creates and maintains them is accelerating. The Boötes Void approaches completion. The other voids follow their own development arcs. In cosmically short timescales, these structures will reach maturity. What happens at maturity? What do fully developed structured voids do? The answer determines our universe's fate. One possibility, they are seeds, templates for new physics. When they activate, they convert surrounding space to their type. Normal physics changes to the physics operating inside voids. The conversion spreads outward at light speed. Eventually, the entire universe transforms. This would be catastrophic for life as we know it. Biology depends on specific physical laws. Change those laws, and existing organisms cannot function. Stars might burn differently. Atoms might bond differently. Everything familiar would cease working, or maybe activation creates connections. The voids link up somehow, form a network that spans the observable universe. What uses does a universe-spanning network have? Communication? Transportation? Power distribution? The scale exceeds anything imaginable, but the structure suggests utility. A more optimistic possibility: the voids are preparing for something cosmic. The universe is approaching a transition point. Vacuum decay, heat death, big rip. Whatever comes next, the voids are infrastructure for survival. Lifeboats, safe zones, regions where reality can persist despite cosmic catastrophe. If advanced civilizations built the voids as survival structures, maybe they will share that protection. Maybe discovering them is the test.